Good morning. This class we are discussing an interesting rearrangement happening in alcohols. The rearrangement. Pinacolone rearrangement. Okay, look at it here. What is pinacolone rearrangement? When completely substituted 1,2-diols, when treated with mineral acid, will undergo dehydration and rearrangement to give ketones. This rearrangement is known as a pinacolone rearrangement. Once again, when completely substituted 1,2-diols, they are known as pinacols, and we get when completely substituted 1,2-diols when treated with mineral acid will undergo dehydration, that means removal of water, and a rearrangement, and we get ketones. That ketones are called pinacolones. Okay, so I can write it. When completely substituted 1,2-diols, completely substituted 1,2-diols. These are called pinacols. Pinacol. Completely substituted 1,2-diol is called pinacol. Is treated with mineral acids. Will undergo dehydration and rearrangement to give ketone called pinacolone. So I can write an example for what you mean by completely substituted 1,2-diol. Okay, completely substituted 1,2-diol. Look at here. CH3. Here it is OH, and here it is OH. Okay, before that, look at here. What do you mean by unsubstituted diol? Look at here. CH2OH. This is unsubstituted ethylene glycol, unsubstituted diol. What do you mean by unsubstituted diol? The OH is attached to this carbon, and this carbon is connected to our normal hydrogen atom. There is no substitution here. Similarly, here also OH is attached to this carbon. That carbon is joined with the two other hydrogen atoms. That means there is no substitution. But look at here. You can see that here the OH is attached to this carbon. Instead of these two hydrogen atoms, there are two alkyl group. That means completely substituted. This carbon is completely substituted. Similarly, this OH is attached to this carbon. That carbon is joined with the two other methyl group. That means this carbon also completely substituted. What do you mean by 1,2-diol? In adjacent carbon atom, if you take this as 1 and this is 2, you can see that in 1 and 2 there are OH group. This is called 1,2-diol, and this is an example for completely substituted 1,2-diol. And what is the name of this completely substituted 1,2-diol? Look at here. 1, 2, 3, 4. Okay, and you can see that 2 in the second carbon, or if you count it from here also, what is that? 1, 2. Okay, in the second carbon there is a methyl group. Similarly, in the third carbon also there is a methyl group. So how will you write? 2, 3 dimethyl. 2, 3 dimethyl. So 1, 2, 3, 4. So 2, 3 dimethyl. What is 4 carbon? Butane. 2 butane. And you can see that 1, 2, 3. In 2 and 3, what is there? OH group. So butane 2, 3 diol. Correct? So look at here. 2, 3 dimethyl butane, again 2, 3 diol. This is an example for what is this one? This is a pinacol. Okay, So what do you mean by Pinacol? Completely substituted 1,2 diodes. They are called Pinacols. So this is an example for Pinacol. Okay, so you can see that this is 1,2 diode, completely substituted 1,2 diode. This is an example for Pinacol. When treated with the mineral acid, that means any acid you can take HCl, H2SO4, HNO3, or generally how will you represent H plus when treated with the mineral acid will undergo, when treated with a mineral acid, okay, here it is completed, will undergo dehydration. What do you mean by dehydration? That means removal of water minus H2O, removal of water, and rearrangement. After dehydration, it will undergo rearrangement to give a ketone. Okay, and suppose you are getting a ketone like this, CH3C, okay, CH3C double bond O, C, CH3, CH3, CH3. Okay, okay, I will get a ketone, and you get this ketone is known as Pinacol, not pinacolone. Okay, this is known as a pinacolone. What is the particular specific name of this pinacolone? You can see that here is the functional group. Okay, so 1, 2, 3, 4. In the third carbon, there is a there are 2 methyl groups. So what is that? 3, 3. So keep it in mind. 1, because this CO group must get the lowest possible number. So 1, 2, 3. In the third carbon, there are 2 methyl groups. So 3, 3 dimethyl. 3, 3 dimethyl. What is this 4 carbon ketone? Butanone. Okay, this is an example for pinacolone. What is that? 3, 3 dimethyl butanone. So this rearrangement is known as pinacolone rearrangement. So first you study what is the rearrangement, pinacolone rearrangement. What is that? When completely substituted 1,2 diode. Okay, this type of diode, completely substituted 1,2 diode, which is known as Pinacol. Okay, which is known as Pinacol, is treated with mineral acid, will undergo, then what will happen? Will undergo dehydration, removal of water, and it will change into a ketone that is known as pinacolone. This rearrangement is known as pinacolone rearrangement. Okay, and okay, let us go through the mechanism of this reaction. How we are converting Pinacol to pinacolone. Let us go through the mechanism of pinacolone rearrangement. Mechanism. Step 1. So here is the mechanism. Step 1. Protonation of 1,2 diode. Protonation of 1,2 diode. This is the first step. Protonation of 1,2 diode. What do you mean by protonation of 1,2 diode? So we are taking the example, the same example. What is that? CH3, CH3. Here it is OH. Second again another carbon CH3, CH3, OH. Okay. This is a completely substituted 1,2 diode. This is an example for Pinacol. So this Pinacol, what is the first step? What is that? Treated with mineral acid. That means H plus. And you can see that here is OH group and here is also OH group. The OH group is having, oxygen is having lone pair electron, or this also having, okay, there are 2 pairs are there. So the lone pair electron on this OH group or on this oxygen as well as on this oxygen. And you can see that this OH group and this one, but they are in the same atmosphere. But that means this is a symmetrical 1,2 diode. Okay, this side and this side and this side, same type of that means this is a symmetrical diode because OH group is attached to this carbon is joined with the 2 other methyl groups. Similarly, this OH attached to this carbon, this is also joined with 2 other methyl group. There is no change between this OH group attached to carbon or this OH group attached to carbon. That means OH attached to carbon atoms are in the same atmosphere. Therefore, the lone pair electron present on this oxygen can abstract H plus, or the lone pair electron present on this O group can abstract, can take this H plus. Makes no difference. You will get the same product. Okay, let us see what will happen. if the electron present on this lone pair electron, okay, this lone pair electron present on this oxygen will abstract this H plus ion, will take this H plus ion. Why it is taking plus this H plus ion? Because lone pair electron negatively charged. Here it is H plus proton. It will abstract, it will take this H plus towards oxygen. So what will happen? This is what is called protonation. Protonation means this OH group is protonated, H plus is coming to OH. So we get a structure like this: CH3, CH3. Here it is OH, and here it is CH3, CH3. Here it is OH, and the new bond is forming OH, and therefore oxygen is getting a positive charge. Okay, here is our old OH, and you can see that this lone pair is taking, or this lone pair is donating to H plus to make a new bond. Since oxygen is giving this pair of electron, oxygen is getting a positive charge. Okay, this is protonated 1,2 diode. Protonated 1,2 diode. Okay, the OH group is protonated. Okay, and keep it in mind, if it is if the H plus is going to this OH group, then also you are getting the same product. Here it will become OH2 like this. Okay, there is no difference between this one, or if it is protonated, here also same only. So we can take this as our example. So here it is a protonated diode. I think this step is clear to you. What is that? This lone pair electron is taking H plus ion, and what will happen? It will make a new bond. Since oxygen is giving its electron, the oxygen atom is getting a positive charge. Okay, and you can see that the structure is like this. And in the next step, in the second step, step 2, formation of carbocation by the loss of water molecule from the protonated 1,2 diode. From the protonated 1,2 diode. Loss of formation of carbocation by the loss of water molecule from the protonated 1,2 diode. So again I am writing the same structure here. You can see that CH3, C, here it is CH3, here it is OH, and here it is CH3, here it is CH3, and here it will become OH2 or H2 with a positive charge. Now what will happen? Immediately, since the oxygen is having a positive charge, for stability, what will happen? This bond breaks from carbon, and it will move to oxygen. That means this pair of electron, that means if the bond is breaking from carbon. A bond means it's a pair of electron, and it is breaking from carbon and it is moving to oxygen. That means the oxygen is getting back a pair of electron, and what will happen? It will change in the form of H2O. That means here what will eliminate H2O. So there is no more positive charge. Okay, since these two electrons are moving to oxygen, the positive charge is removed. And what will be eliminated? H2O minus H2O, and what we will get CH3, CH3. Here it is OH, and here it is C, and here it is CH3. Here it is CH3. Since the bond is breaking from carbon, the carbon is getting a positive charge, and this is a carbocation. Clear? The second step, formation of a carbocation. So if it is very clear, since oxygen is having a positive charge, what will happen? The bond breaks from carbon, and this pair of electron will be moved to oxygen. Therefore, it will change into it will depart as a separate H2O molecule. So minus H2O is removed, eliminated, and we get a carbocation. This is the second step. Third step, step 3. Step 3. Rearrangement of Carbocation. Carbocation. Rearrangement of carbocation. Look at here. Here we are having a carbocation and third step, rearrangement of carbocation. So I am writing the same carbocation. CH3, CH3. Here it is OH. Here it is CH3, CH3. Okay, here it is a positive charge. This is our carbocation. Carbocation. When this carbocation is formed, look at here. If such carbocation, that means here the positively charged carbon is attached to another carbon. In that carbon there is OH group, and since there is no hydrogen atom, and that means this carbon is also completely substituted. So in such cases, what will happen if there is a positive charge here and adjacent carbon there is OH, and in the same carbon there are alkyl group or aryl group, there is no hydrogen. That point is important because hydrogen is here means by hyperconjugation it will stabilize. Since there is no hydrogen, only the alkyl groups are present. What will happen? You can see that one of the alkyl groups, that means here this is CH3 and this is also CH3. One of the alkyl groups will be migrated from this carbon to this positively charged carbon. Once again, so what is the third step? Rearrangement of the carbocation. Rearrangement of the carbocation means the alkyl group present on this carbon, on the adjacent carbon, or the alkyl group present on the OH attached to carbon will be migrated from this carbon to this carbon. Okay, positively charged carbon. Okay, for more clarity, I can write it like this. Okay, keep it in mind. Look at it here. Okay, here it is CH3, and I can write this CH3 down, CH3. Okay, clear. Okay, here is a positive charge. Okay, now what is happening? As I told you, what is that? Such carbocation, in this case, what will happen? One of the alkyl groups, this alkyl group or this alkyl group, one of the alkyl group will be migrated from this carbon to this carbon. Okay, so what do we get? Look at here, what we get? CH3, here it is CHC, here it is OH, and since this bond is breaking from this carbon is getting a positive charge. Now this is our carbocation, and here it is what is happening. This CH3 group is coming to this carbon, so here it is CH3, CH3, CH3. Correct? Okay, okay. Now in the next step, you can see that in the next step, fourth step, you can see that this carbocation. Okay. Fourth one, stabilization of this carbocation, stabilization of carbocation. Okay, look at here how this carbocation is stabilizing. So I think this step is clear. Since here is a positive charge, what will happen? The OH attached carbon, from this carbon, one of the alkyl group will be shifted to this positively charged carbon, and we get a carbocation like this. This carbocation can be immediately stabilized. How it is stabilized? Look at it here, CH3, C, here it is positive charge, here it is OH, and here it is CH3, CH3. Now you can see that this oxygen is having lone pair electron. Okay, this oxygen is having lone pair electron. Since this carbon is having a positive charge, what will happen? This pair of electron will be attracted here. That means this pair of electron, oxygen having lone pair electron, that lone pair electron, one of the lone pairs, this lone pair electron will be shifted between carbon and oxygen. That means here it will become a double bond. Then that time the positive charge will be removed because carbon is having positive. That is the reason why, since this carbon is having a positive charge, that is the reason the negatively charged electrons are shifting to here. So what we get? We get a structure like this. Here it is CH3, C, and here it is double bond OH. Since the electrons are moved to here, or since the lone pair electrons are donated for bond formation, this oxygen is getting a positive charge, and here it is CH3, CH3, CH3. Okay, we get this is a actually this is CH3, C double bond O. In that oxygen there is a hydrogen. That means this is a protonated ketone. Protonated ketone. Protonated ketone. Okay, this is protonated ketone. I think this step is clear to you. This pair of electron, lone pair electron is shifting to here. So what will happen? Since the electrons are moving from oxygen, oxygen is getting a positive charge, and of course here it will be a double bond, and there is no more positive charge on the carbon atom, and we get a protonated ketone. Okay, last step. Last step. That means for fifth step, deprotonation. Deprotonation of ketone to give pinacolone or ketone. Okay, to give pinacolone. That means CH3, C double bond OH with a positive charge. Okay, and here it is CH3, CH3, CH3. What do you mean by deprotonation? Now you can see that this structure is unstable because the oxygen is having a positive charge. For stability, what will happen? This bond breaks from hydrogen and it will be moved to oxygen. That means this pair of electron, this bond means a pair of electron. This pair of electron is moving, the bond is breaking from hydrogen. That means hydrogen is removed as H plus without its electron. This bond